So this is section 3.3, summaries for skewed distributions. So every time we're looking at a distribution, we've been talking about deciding on its shape. And then we want to talk about the distribution center and spread. So in this section, we're going to be focusing on the shape when we have a skewed distribution. And we're going to talk about what measures of center and spread are appropriate when the distribution is skewed. We've already talked about in the previous section what measures of spread and center are good for a symmetric distribution. So we had seen the mean and the standard deviation. So starting the notes here, since the mean is not resistant to outliers, it's not the best measure of center to use in a skewed distribution. We saw that the mean gets pulled in the direction of the tail or towards an outlier. So let's go back and look at this distribution that we saw in the previous section for salaries of professional baseball players. The mean salary was 3.2 million, and we had talked about how this doesn't seem like a typical salary. So this may not be the best method or to talk about a typical value. A better method might be to think about, well, where do you think the middle observation is? Like, if we lined them all up, what salary would be right in the middle? And likely the middle salary would be more over here. There's the frequency of being less than 1 million is so much more than being more than 1 million. So we might expect our middle value to be somewhere in there around, let's just say around 1 million for this. So this value that we're looking at, the middle value, is a useful measure of center for a skewed distribution, and it has a name. It's called the median. The median is a numerical summary that measures the center of the distribution. Like the mean, it gives us a typical value for a set of data. The median value cuts the distribution roughly in half. So 50% of the observations of the distribution are below the mean, below the median, and 50% are going to be above it. So the following distribution contains incomes of 1,000 New York State residents. It's drawn from a survey by the U.S. government in 2011. The mean income is 42,000, and it's marked with a triangle on the axes. Estimate the percentage of residents that earn more than the mean income. In other words, we want to know how many observations fall on this side of the mean. So it looks like not nearly as many as fall on the below side, so maybe about 25%, which would mean that 75% of the distribution is below the mean. So that doesn't sound like a typical value, way to describe a typical value for this distribution. The following histogram shows the same distribution. Okay, so we're still looking at the same distribution, but the vertical line's indicating the median income. And so this line comes at 25,000, and it cuts the area of the histogram in half. Again, so half the observations are below this line, and half of the observations are above this line. So this is probably a better summary of the center of the distribution. So how would we calculate a median? So like the mean, we can use technology to do it. but we can also do it by hand, and you will have to be able to do some small data sets by hand. So here are the steps for calculating the median. We want to sort our data from smallest to largest. Okay, if the data set contains an odd number of observations, the median is the middle observed value. If the data set contains an even number of observations, the median is the average of the two middle observed values. So let's go through and do an example. One more note here is that we can use this formula. It says n plus 1 over 2 to find the position of the mean. Okay, I'll show you how you use this. It's not fine. Okay, sorry, I made a mistake when I said that. Position of the median. It's not finding the median, it's finding the location of the median. So we'll use that to show how to use that little helping formula. So first, let's look at this first data set. We need to know how many data observations are in our data set, and it looks like 7. So our n for this is 7. And if we just, since it's so small, we can actually visually kind of cut it in half. We have 3 data points that are below this middle value here and 3 data points that are above the middle value. So since this is odd, the median is our actual middle value. Median equals 8 for this data set. If we were to use this formula to find the position of the median, we would say, oh, okay, there's 7 data points plus 1 divided by 2, so that gives me 4. That's the 4th position is going to have the median. So if we counted over 1, 2, 3, 4, this is the 4th position. So again, we'd find the median that way. Looking at the next data set, we now have n equals 8. So this is an example of an even, which we talked about above. It means that we're going to split our data set in half, and then we're going to find the average of the 2 middle values. So we have 4 values on that half, 4 values on that half. The median is going to be the average of these 2 middle values. So in this case, the median is 9. Okay, so let's look at this next data set. It's very similar to the previous one. It also has 8 values. But notice this last value is slightly different. We have 16,000 instead of 16. This could be a potential outlier. And let's see what happens to the median. We already know the mean would get pulled up in this direction toward the 16,000. But if we take a look at the median, again, we'd split our data set in half because there are 8 data points. And we take the average of the middle 2. And we once again come with 9. So even though that we have a outlier, potential outlier in this data set, our median doesn't change. So that's one of the reasons why it's such a good summary of center for a skewed data set. Okay, the following dot plot shows the percentage of fat for each of 10 types of ham. Okay, so n equals 10 at a grocery store. Find the median for this data set. So I'm noticing that n equals 10. I'm going to need to take the average because it's an even number. So starting at this side, I have 1, 2, 3, 4, 5. So my 5th value is 22. And my 6th value is 25. So I'm going to have to find the average between 22 and 25. And that comes out to be 23.5. And so your median would be right there. So based on your answers from above, do you think the median is resistant to outliers? And yes, this data set up here is a little bit skewed. And the median isn't getting pulled in the direction of these really big data points. And the data set we saw just above that here with the 16,000, we noticed the median didn't change. So it is what we would say is resistant to outliers. So let's take a little closer look. Oh, some of my graph got ruined. Hold on one second. Let me see if I can fix. Okay, I had to fix our dot plots there. They were getting crunched for some reason. So let's take a closer look at how the mean and median are affected by outliers. So we have the mean and median marked on the graph here. And this is our median. Let's see, our median. And this is our mean. And so we can see that our last data point is right here in the first dot plot. But if someone were to have actually an outlier of 65% of fat in ham, you can see how the mean got pulled in the direction of this outlier. And so the mean, we can say the mean follows the tail, or the mean is pulled in the direction of an outlier, whereas the median is resistant. So it's better to use median as a measure of center in skewed distributions. Now, let's think about the standard deviation. Do you think the standard deviation is resistant to potential outliers? And resistant means it's not going to change when you have an outlier. And I would say no. I mean, the standard deviation uses all of the data points to calculate it. And it's based on the mean, which we already know is not resistant. So the standard deviation isn't going to be a good measure of spread for skewed distribution. So let's also just look at one more piece of information about the standard deviation. Here are some statistical outputs from technology. And here on the one side, let's see, we have the New England Patriots. The left side's including Tom Brady's age during the 2015 season. And the output on the right shows what would happen if he continued to play till he was 60 years old. Okay, so we have a bit of an outlier over here. And you can see the way we would read this is that the first line, this is our mean. The second line is our median. And the third line is our standard deviation. So you can look at these two outputs and you can see the mean increased, the median stayed the same, and the standard deviation increased. So again, that's just showing you that with an outlier, the standard deviation will change, and it might not be a good measure of spread for a skewed distribution. Let's get this out of our way. So since the standard deviation is not resistant to potential outliers, we need to look for a better measure of spread for a skewed distribution. This measure that we're going to be using is called the IQR, the interquartile range. And what it does is it's a summary that measures the spread of the distribution for the middle 50% of the data. Okay, and so we're going to talk about how we can calculate the IQR. Steps for calculating the IQR. First, we're going to find the median, which we saw how to do that. And the median will also have another name. We can call it Q2. It's the second quartile. So we're going to break our distribution down into 4 quartiles. The first one's going to have 25% of the data. The second quartile is going to show us where 50% of the data is, and so on. So the median of the lower half of the data set, so once we found the middle value of the data set, we're going to break the lower half again, and that's going to find the first quartile, or where 25% of our data is. And then we're going to do the same thing for the upper half and find the third quartile. So when we calculate this by hand, we do not use the median in either half of the data set. And then the final step here is that once we've found our third quartile and our first quartile, we're going to find the difference between those two and see what's the spread of the middle 50% of our data. So this might sound a little complicated, but we're going to walk right through an example here and sort out those directions. So there are several accepted methods for calculating quartiles. We're first going to do it by hand, and then we're going to see how StatCrunch does it, and you'll see that the method that we use by hand, which is the typical method, is slightly different than StatCrunch, but that's okay. I just want you to be aware of it. So first, we need to find our median. And so we need to know how many data points we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So n equals 9. So that's an odd number. Our median is going to be a middle data point right here. This is our median. Okay, and also known as Q2. So 50% of our data is going to be lower than that, and about 50% is going to be greater than 24. Next, we're going to take our lower data set, not including our median, and cut this data set in half, finding basically the median of these 4 observations. So it's an even number, so we're going to have to average 10 plus 20. It's going to give us 15, and that will be our Q1. So our lower quartile is 15, and then we can do the same thing on this side. We've got this little data set that we're going to find the median of again, and we're going to have to average 45 and 50, and that comes out to be 47. Oops. 47.5, and this is our Q3. So now we have the pieces we need to find our IQR. Our IQR, interquartile range, is the difference between Q3 and Q1. So 47.5 minus 15 is equal to 32.5. Okay, so now let's see what StatCrunch does when it calculates the IQR. So StatCrunch does the same thing and finds the median. The median hasn't changed. It's right here. That's our Q2, we'll call it. But what StatCrunch does is it uses the median in both of its calculations for finding Q1 and Q3. So this data set, it takes the median and uses it. And so we're going to find the middle value, which is 20. And then to find the the Q3, it's going to use, whoa, that was not what I meant to do. Use Q3 again. It's going to use the median again, and so the middle value will be this 45. So this is Q3. So the IQR, if StatCrunch were to calculate this, would be Q3 minus Q1, which is equal to 45 minus 20, and it's equal to 25. So we also saw previously the range as a measure of spread. We're trying to measure the spread. And remember, that's just the max value minus the minimum. So in our case here, it would be 60 minus 0, which is 60. Okay, so let's flip the page. Okay, so let's go ahead and find the range in the IQR for the next data set. So let's see here. We have n equal 1, 2, 3, 4, 5, 6, 7. N equals 7, so our middle value is going to be 8. This is my Q2. By hand, I'm going to just use these and these to find Q1. So Q1 equals 4, and Q3 equals 12. The IQR will equal 12 minus 4, which equals 8. The range is going to be your maximum value, 14, minus your minimum, which is 12. Okay, let's do it again for one more data set. So this data set has 8 observations. So this will give us a little practice when we have an odd number. So our median, which we found earlier, was Q2 equals 9, the average between 8 and 10. Since we didn't use either 8 or 8, since 8 and 10 aren't our medians, we are going to use both these values in the data set because the median's right between there, okay? So now to find Q1, we're going to have to average 4 and 6. So Q1 equals 5 and Q3 equals 13. That means our IQR is 13 minus 5, which is 8. And our range is 16 minus 2, which is 14. Okay, so let's see what happens when we have this outlier in here. We already saw the median wasn't affected by it, but what about the range in the IQR? So quickly, I'm going to go. The median here is 9. That's our Q2, right? And we're going to use this again to find Q1, which equals 5, and this to find Q3, which doesn't get changed by that outlier. So our IQR stays the same, 13 minus 5, which is 8. Let's see what happens to the range. The range is going to use our maximum value, 16,000 minus 2. So this changes quite a bit. So the range is not resistant to outliers. Which measure of spread is resistant to outliers? The IQR. That didn't change when we had an outlier. How does the IQR differ from the range? The range is the spread of all data. Where IQR is looking at the middle spread of the middle 50%. IQR is spread of middle 50%. Okay, we have one last example here. The quartiles cut the distribution into 4 parts. So roughly 25% of the data is below Q1, 50% of the data is below Q2, 75% of the data is below Q3. So between each of these lines is roughly 25% of the data. If we were to calculate our IQR here, we would need to know Q3, which looks to be about 160, and Q1, which maybe is 121. I'm estimating off the graph. And that comes out to be 30, oops, I forgot the 3, so 39 pounds. Okay, so that really wraps up this section. The summary of the section is that when you're looking at your distribution and your shape is skewed or you have outliers, your measure of center will be your median, and your measure of spread will be your IQR. So remember, your technology will produce a median or a mean, standard deviation or IQR for any data set. It's up to you to check the shape and choose the right measure of center and spread to report.